Today, we're diving into a set of ideas that are, well, just remarkably simple, but also incredibly powerful when it comes to finding the best answer to some really complex problems. We're talking about the Rao algorithms. But let's kick things off with a question that, honestly, we all face in some way or another. Whether you're trying to design a more efficient jet engine or you're just trying to bake the perfect cookie, you are constantly on the hunt for the best possible outcome. But when your options are practically infinite, where do you even start looking for that one single perfect solution? This whole quest for the best is really the heart of a field called optimization. It's all about creating a systematic way to find that perfect answer, and we're about to see exactly how it's done. Okay, to really get a handle on this, I want you to picture a team of hikers. They're scattered all across this huge, hilly landscape, and it's super foggy. Their one and only goal? Find the absolute lowest point in the entire area, the very bottom of the valley. Now here's the catch. They can't see the whole map. They can only see what's right around them and talk to each other. This search, this whole scenario, that is exactly what optimization algorithms are built to do. Now, most of the algorithms that try to solve this kind of problem are really complex. I'm talking lots of dials and knobs that you need to be an expert to tune just right. But what if I told you there was a much, much simpler way? Well, that's the whole idea behind the Rao algorithms, developed by Dr. Ravipudi Venkatada Rao. And this is the secret sauce, the thing that makes these algorithms so special. They are parameter-free. What that means is you don't have to be some PhD to get them running. They just work. It's a pretty radical idea, this dose of simplicity in a field that's usually all about complexity. All right, so how does this actually work? Let's take a look at the first version, Rao 1. The strategy here is so intuitive, it's brilliant. You just learn from the very best and the very worst performers in your group. So here's the game plan. Our team of hikers, they all start at random spots. Then, they all figure out who's currently closest to the bottom of the valley, that's our best hiker, and who's stuck way up high on some peak, that's our worst. In the very next step, every single other hiker adjusts their own position by moving just a little bit towards the best one and a little bit away from the worst one. And that's it. Then they just do it all over again. So here's our starting lineup. We've got 5 hikers and their positions. That f of x value, just think of it as their altitude. Right off the bat, hiker 4 has found the lowest spot so far, at an altitude of 113. That makes them our current best. Meanwhile, poor hiker 2 is way, way up high at 1285, making them our worst. So 113, that's our current record. It's the number to beat. Now, after just one round, one single step, every hiker adjusts their position based on where our best and worst are. And bam, look at that. Hiker 1 has now found a spot that's much lower, with a new best altitude of 76.84. We've got a new leader. I mean, that's a pretty huge improvement, right? We went from a best score of 113 all the way down to just under 77. The entire group is getting closer to the answer just by following this one simple rule. So, what happens if we run it again? Well, the process just repeats itself. The group finds the new best and worst, and everybody adjusts. And this time, hiker 3 makes a massive leap forward, finding a spot with an altitude of just over 24. In just 2 steps, the team is rapidly, and I mean rapidly, closing in on the best possible answer. It's pretty amazing to watch. But, learning from only the absolute best and worst isn't the only way to do it. The other Rao algorithms, Rao 2 and Rao 3, they add another simple little twist, learning from your peers. So here's the key difference. With Rao 1, everybody is focused on the group's single leader and the person lagging behind. But with Rao 2 and Rao 3, there's a second layer of learning. Each hiker also learns from another randomly chosen hiker. You can think of it like sharing tips with the person hiking right next to you. And this peer-to-peer chat is really important. It helps stop everyone from just blindly following one person down a dead end. It encourages a much smarter exploration of the whole landscape. So this is all pretty cool, right? But what does it actually mean in the real world? I mean, why is a simple algorithm like this such a big deal? Well, the advantages are just huge. First, their simplicity means they're super easy to code and use. And because there's nothing to tune, you don't waste time messing around with settings. But here's the kicker. They perform just as well as, and sometimes even better than, way more complicated methods. And they do it without needing a ton of computing power. And you don't have to take my word for it. The creator himself, Dr. Rao, sums it up perfectly. He says these algorithms give us a reliable and efficient tool for solving all sorts of real-world engineering challenges. And that leaves us with a really fascinating thought to chew on. In a world that so often assumes that complex problems must need complex solutions, the Rao algorithms kind of prove the opposite, that sometimes the most powerful way forward is actually the simplest. It really makes you wonder, doesn't it? Where else could we solve a big problem with just a dose of radical simplicity?